We're moving on to solving exponential equations using algebra now. And the basic process we will follow for solving all of these equations is outlined at the beginning of your lesson. That process is to get the base the same on both sides of the equation, and then set the exponents equal to each other and solve. We're going to go through some examples so you can see what I mean. In the first case, it says 3 to the exponent x equals 27. We need to get the base the same on both sides of the equation. So the base I'm going to choose obviously will be 3. 27 can be written as 3 to the exponent 3. Therefore, if 3 to the exponent x equals 3 to the exponent 3, I can set the exponents equal, and I have my result, x equals 3. Next one, same thing. In this case, we're going to choose a base of 9. Now, 6,561, using a calculator, is equivalent to 9 to the exponent 4. So that tells us in this case that t is equal to 4. In the next one, the base is negative 4. So I'm going to have to use the same base on the right-hand side of the equal sign. Now, 4,096 can be written as negative 4 to the exponent 6. Again, using a calculator to find that value, just repeatedly multiplying negative 4 times negative 4 until we get 4,096. So it would take 6 times, so m is equal to 6. Next one, negative 5 to the exponent x equals negative 125, which can be written as negative 5 cubed, because negative 5 times negative 5 times negative 5 is negative 125. Set the exponents equal, so x is 3. Okay, those ones are all pretty straightforward. Next one, 4 to the exponent x plus 3 equals 1,024. 1,024 can be written as 4 to the exponent 5. So now I have the base the same on both sides of the equal sign. Step 2 is to set the exponents equal to each other and solve. So in this case, if x plus 3 equals 5, we know that x must equal 2. In part F, we're going to use a base of 5. So we have 5 to the exponent m minus 3. Now 78,125 is the same as 5 to the exponent 7. Again, just using a calculator, trial and error to find that number. M minus 3 then equals 7. So m is equal to 10. Next one, we could use a common base of 3 on both sides. So 3 to the exponent 2k equals 3 to the exponent 4. Set the exponents equal and solve for k. So dividing by 2 on both sides, we find out that k is 2. The next one's a little different because we have a 2 being multiplied in front of the first term. So this one we're going to start by dividing that 2 out of there. So on the left-hand side of the equation, we'd be left with 4 to the 2x, and on the right-hand side, that would equal 16. Get the base the same on both sides, so we'll use a base of 4. 16 is the same as 4 squared. Now set the exponents equal and solve. So in this case, x equals 1. The next one's a little different as well because on the right side of the equal sign we have a 1. And on the left side the base is 5. I can write 1 using a base of 5 if I make the exponent 0, because remember anything to the exponent 0 is 1. So I'm going to choose the base of 5 because that's the base I have on the left-hand side. Now set the exponents equal and solve for x. So that means 3x would equal negative 1, subtracting 1 from both sides. Divide by 3, so x is equal to negative 1/3. Now, in question J, we run into a different situation again. There's no exponent I can put on 25 to get 125 as an answer, because 25 squared is already way bigger than 125. 25 times 25 is a very large number. So that doesn't work. So what we have to do is find a base that I could use for both of those. Now 25 and 125 can both be written as powers of 5. So I'm going to write 25 as 5 squared and we still have to the 2x on the outside here of these brackets. And 125 I'm going to write as 5 cubed, and we still have x minus 1 outside there as well. So I've replaced the base, or I've rewritten, I guess we should say, each base as a power of 5. So I haven't changed the question, I've just written both sides with a common base. Now we're going to simplify in the exponents here. So this would be the same as 5 to the exponent 4x, and on the right we need to apply the distributive law because both of these parts need to be multiplied by 3. So on the right we'll have 5 to the 3x minus 5. Now we have the base the same on both sides. We're going to set the exponents equal and solve. So we'll subtract 3x from both sides. So our answer is x equals negative 5. The same thing happens in the next example. So I can't write 8 as a power of 4. 4 times 4 is already 16. That's bigger than 8. So we're going to have to get another common base. So we'll use 2. I can write 4 as 2 squared. So it will be 2 squared to the 3x. And I can write 8 as 2 cubed. So it will be 2 cubed to the 4x minus 1. Simplify the exponents. So we'll have 2 to the 6x and 2 to the 12x minus 3. Set the exponents equal and solve. Subtract 12x from both sides. That gives us negative 6x equals negative 3. Divide both sides by negative 6, so x equals 1/2. And in the last one, the common base for both of these numbers would be 3. So I can write 9 as 3 squared to the x. And 27 I can write as 3 cubed to the x minus 1. Simplify the exponents, so we'll have 3 to the 2x and 3 to the 3x minus 3. When you're doing questions like this, just don't forget to multiply the 3 by both parts. Set the exponents equal and solve. Start by subtracting 3x from both sides. That gives us negative 1x equals negative 3. Divide both sides by negative 1, so x is equal to 3. And that concludes your lesson.